good news here. There are a few where you have to do truth tables, but there are a few where you don't. So let's look at those that way. Yeah, if you look in the book at this section in your probably at the sort of beginning of it. What you'll see there are some argument forms. See those? The little table. Argument forms. These are known argument forms, and we're going to utilize that. Keep this one in mind here. Just we'll say more about that one in just a second. Everybody find them? Mm-hmm. No. Right there. Find them? Right there. Okay. All right. Yeah, there's a table that has valid argument forms, and invalid argument forms. Well, let me write them up here. All right, so we got valid argument forms. What's the first one? Modus ponens? Huh? Modus ponens. Okay, that's the first one. Like I said, these are named forms or valid known forms. All right. Modus ponens goes P arrow Q, P, therefore Q. Hey, does that one look familiar? Yeah, that's the first one we did. Then we have modus tollens. It goes P arrow Q, not Q, therefore not P. Then we have disjunctive syllogism. Syllogism, by the way, is just a name for argument. So disjunctive syllogism is P or Q, not P, therefore Q. And then last but not least, reasoning by transitivity. Which goes P arrow Q, Q arrow R, therefore conclusion P arrow R. Those are the four shown on that table, right? Well, there's also a couple of invalid argument forms. Two of those. What's the first one? Fallacy of the converse, okay. And it's P arrow Q. Q, therefore P. And then the second one is fallacy of the inverse. And it's P arrow Q, not P, therefore not Q. Okay. The good news on these. A couple of these we've done, but the rest of them have been done too. And they have been proven to be valid or invalid, depending on the one we're talking about. Right? We did this one. We did modus ponens. And what other one did we do? I believe we did fallacy of the inverse. Right? That's one of the ones we did. So we did prove those, but the others as well have been proven. So no need to go back and rehash those. If we can match up an argument to one of these, we can definitely tell if it's invalid or not, just by matching it up. And that's kind of how we're going to do it this other way. What I would say is the third one we did by the truth table, we actually did this one, but not quite. The one we did was P or Q. What was this? Back on the truth table ones. Not Q, therefore P. Turns out on the disjunctive syllogism, this is the only one you can do this with, you can flip-flop these around. This disjunctive syllogism could be this, or it could be this. Just note that, because I think there might be one in the homework where it's flip-flopped around. But that's the only one you can do it with, because notice, if I flip-flop these around, make this not P and this not Q, not P here, not Q there, that's fallacy. So if you flip-flop these around, or you flip-flop this around, it makes it a fallacy. But not so on the disjunctive syllogism. So make note of that. Okay, here's how we use those. All right, let's say we have this. We're going to rewrite in symbols the argument, and then match with a known argument form, and determine if it's valid that way. Basics of it. Instead of having to use a truth table, just match it up. Rewrite it in symbols and then match it up with a known form. Okay, here's number one. The floor is dirty. No, that's if the floor is dirty, I will mop it. Okay? The floor is dirty. Conclusion, I mop the floor. I will mop the floor. Okay. So if I rewrite that in symbols, and you can use your own letters if you want to, but P's and Q's, since that's what the table has, that's what I recommend you do. You don't have to, but because it works S arrow T, S, T, it works the same way with different letters, but these do have P's and Q's, so I'm going to use that. All right, so if the floor is dirty, I will mop it. That would be what in symbols? Well, that's an arrow, isn't it? I've got two things, so that'd be P, arrow, Q. All right. Now, what is the second premise? The floor is dirty. Well, if I say this is P, isn't that the P from the first part? So the second premise is P. And then what's the conclusion? Well, I called it Q, didn't I? So that's that argument in symbols. Now, what does it match up with up over here? Which one of those six? It's modus ponens, isn't it? That's modus ponens. So is it valid? Yes, it is. So yeah, instead of having to go through the whole truth table thing, if I can just match it up with something up here, I'm good to go. Because those have already been proven. You don't have to go back and prove. Okay? So that's the basic idea. All right, number two. If the floor is dirty, I will mop it. Same thing. The floor is not dirty. Conclusion, I will not mop the floor. Okay, well, starts off about the same. That's P arrow Q on top, the first premise, but what about the second premise? Well, the second premise is the floor is not dirty. That's the opposite of the floor is dirty, so that's not P. Conclusion, I will not mop the floor. That's not Q. What about that one? What's that one? This one right here, isn't it? Fallacy of the inverse, invalid. Okay? So it's a little easier. You don't have to go make truth tables and all that. All right, let me give you one more just to show you what this one looks like. Okay? Real quick. Number 3. If the floor is dirty, I will mop it. Same basic start, okay? If I mop the floor, I get tired. Conclusion, if the floor is dirty, I get tired. Well, this one, we've got what? P arrow Q, same start. But what's the second premise? Yeah, the second premise, I start with Q, don't I? I mop the floor, which is Q. And then I go arrow to another statement, I get tired. That's a totally different statement, so that's the R. And then notice the conclusion, the floor is dirty, that's P. Arrow, I get tired, that's R. That's the transitivity, right? Reasoning by transitivity. Which is valid. Okay, so that one, that's how that one works. Kind of, I like to call it the chain rule because it just kind of chains along, and then, yeah. All right.